All right, class, today I'm going to be starting chapter 7, which is all about statistics and probability. So a little bit more probability, we aren't quite done with it yet. And the goal of this chapter is I really want us to get a main overview of statistics, okay? And because of that, I will be deferring from our text a little bit, which gets a little bit too much into the calculations and less into the understanding. So let's start with section 1, and that's all about visual representations of data. So here are some things I'm going to cover today. So the first place I want to start with is, what is statistics? So statistics is a few things. There's a couple ways that statistics is used as a definition, right? Statistics can refer to the science of collecting, analyzing, and interpreting data, right? It can also be the data that we collect. And statistics are pretty prevalent in our lives, right? We see statistics in the news. We see them in the newspaper. We've been seeing a lot of them in reports to COVID-19 and how that's affecting people all over the world. And we collect statistics about a lot of stuff. So 2020 is a census year, right? The census is an example of collecting statistics about the entire population of the United States, right? And we aren't just collecting statistics about health, for instance, by way of COVID-19, but we want to know how many people are in this family. What is their ethnicity? What's their average income? What are their jobs? How many dependents are in the house? Are they married or divorced or just living together? This is really important information, and the government uses that to decide where funds are allocated and how the congressmen are divvied up. So it's really important to collect statistics. So the way statistics works is this. So our goal of statistical research is to gain information about a population being studied, right? When it comes to the census, the population being studied is everybody in the United States, right? And we could call that a population, okay? So the population in a statistical study is the complete set of people or things being studied. And population parameters are the specific characteristics of the population. So the census, for example, surveys the entire population, or really, really close to it, as much of it as possible, in the United States, and uses that information to come up with population parameters. So we're conducting a sample, and we have our population. That's what we want to study. It doesn't have to be people. It could be all American-made cars in 2020. It could be all of the French fries coming out of specific McDonald's, right? The population is whatever we want to study. However, that can be problematic, right? Think about the United States Census. There are over 3 million? No. There's over 300 million people in the United States. That's a ton of people. A ton of people to go talk to and survey individually, right? So sometimes your collection of people or things is too big to study. And so for that, what we want to do is we want to take a sample. So sampling is when we take a portion or subset of a larger population. So if I wanted to study students who took math courses, right, I could study a small group of students at my university, right, because it'd be impossible to study every single student taking math across the world, across the United States, across Missouri. It depends on my parameter, on what population I'm looking at specifically. So we want to take a smaller sample in order to gain information about the population. One thing that's really important, though, and a main concern of statistics, is how accurate a statistics estimates a parameter, right? We want to take a sample and gather information about that sample to calculate a sample statistic that will hopefully inform a population parameter, okay? So we need our sample to be representative of the population we're studying, okay? So for example, if we wanted to study college students, right, and we took a sample, we wouldn't want to pick only women, we wouldn't want to pick only freshmen, right? This sample would not be representative of college students as a whole, okay? So the way that we can pick a representative sample is to pick members of the sample randomly from the population. You could put everybody's name in a hat. You could go systemically and pick every 50th student enrolled in a specific university. There are ways to randomly collect a sample, and we want to make sure that sample is as representative as possible. So, friendly reminder, some definitions. A sample is a subset of a population from which data are actually obtained. So that's who we interview, or that's the cars we look at to see if they have any engine malfunctions. I'm not a car person, guys, but I try. And then from that sample, we collect raw data, right? That's the actual measurements or observation collected from the sample. So if I was sampling a student, I could collect data on their age, GPA, ethnicity, whether they're a first-generation college student. Did they get their GED or high school diploma? What classes are they taking? What's their major? What's their age? There's so many different data we can collect from people, and that's why most people want to study people, because they're the most interesting. And from that raw data, from our sample, we can calculate the sample statistics. Okay, this is just ways of summarizing the data, and we're going to talk about ways to summarize data as we go on in this chapter. Okay, but it's really important to remember that our sample statistics are only good at estimating things for the true population if we have a representative sample. A couple more definitions, right? Data is the information we collect, okay? And if you want the single value of data, it's going to be datum. And I think this is a really weird word, and I've never had to really use it in conversation, but now you know.